Aspire is actually quite powerful when it comes to this kind of thing, using two rail sweeps, being able to use a shape creation, using our sheets feature.
Hi and welcome back to the 2023 User Group Meeting. My name's Ollie and I've been a web developer at Vectric for 5 years now. In this session I'm going to show you how to create a hybrid CNC and laser project focusing on the use of the plate production feature for efficient personalisation. For this project I'll be creating this unique User Group Meeting badge which I'll be personalising for individuals. So let's get started. The first thing we'll need to do is get our software set up with the laser module. If you're interested in the laser module and hybrid machining, I would recommend having a look at the laser module product and trial pages on our website, where we have lots of information, FAQs and some free hybrid machining projects for you to test out your setup. To get the laser module into your software, you'll need to be on version 11 or higher and be using one of our core products, Cut2D, VCarve or Aspire. The laser module is an add-on to the software and cannot be used independently. To trial the laser module, you can download any of our core product trial versions and enable it via the help menu. To buy the laser module, you just need to go to the laser module product page, which will link you to the right place within your portal account. If you do not see the laser module add-on option once in the portal, you may need to scroll down to the add-ons section where you should see it. Once you have purchased the laser module, it will be automatically added to your software, so you will not need to download anything extra. You will need to restart the software and be connected to the internet for this to take effect. Now that we have the laser module, it's time to start designing our vectors for the UGM badge. Okay, so the first thing we need to do is create a new file and set up the job space. So I want a width of 100mm, height of 140mm, thickness of 6mm. We're going to Z0 off the material surface, and then the XY datum is going to be in the bottom left hand corner. So the first thing I want to do is create the outline of the medal. So what I'm going to do is use the draw rectangle tool to create a box. Then I'm going to center it. Okay, the next part I want to be pointed at the bottom. So the way I'm going to do that is create a box of 60 by 60. And then I'm going to rotate it by hitting the R key and then 45 degrees. And then I'm going to center it to that box and to the bottom. For the next step, I'm basically going to be snipping away any vectors that I don't need, because we don't need these. We just want the point. I've ticked the rejoin the trim vector section, part of the form, so that it will rejoin all the vectors automatically. Just go through and cut out any vectors we don't want. Close that down, and then you'll see that we don't need to join any vectors. They're already all joined for us. Next part is we don't want these square corners. We kind of want a rounded corner, so we're going to go in and fillet these. Okay, for this bit we're going to offset in by about 5mm. So this is going to basically create the basis for where we're going to pocket out. Okay, so we've got that there. So the next step is I want a bit of a gap at the top to put a hole through the material, so you can put a ribbon or some thread through to hang the medal or badge around your neck. So I'm going to go with a width 16, 10.5. So this is just going to be a guide for where to position these vectors. So I'm just going to go into node editing mode, move these down to the bottom of that box. Okay, so that looks good. The next thing I'm going to do while I've still got that box is create the actual hole, or the vector for the hole. It's going to be a width of 15 and a height of 4. We'll then fillet the corners to 2 mil because I want them basically to be a full circle on each end. And I can use this box to center that. And I'll get rid of this guideline. Okay, so it's starting to come together, but so for the next step, I want to create the diagonal line where we're going to do some V-carving, because we're just going to poke out the top and bottom parts here. So I'm going to go in and create a box with a width of 100, so that I'm sure that it will go across, and 11.3 mil in height. So, and then click R on the keyboard again to rotate, and we're going to do this by 15 degrees. We're then going to center it to here, and then by I'm roughly going to line it up. That looks about right. And then we're going to use the trimming tool again to trim out these vectors. And we've still got the rejoin tick on, so that it's going to rejoin all the vectors for us. So for the next step, we're basically going to be offsetting some of these vectors. So we want to offset both of these inwards by 2 mil. And then we can basically now start and adding the text to it. So I'm going to start off by adding the maker, or the text that's going to go here, that's going to be VCarved. So going to draw another rectangle, but this time going to go with a width of 50, and the height I'm going to put as 8. And then rotate it by 15. And then center it to the outside vector. Then move it up until we're happy with where it is. Okay, we'll then click this box. So the font I'm going to go with is Open Sans Extra Bold. And then what I'm basically going to do, rotate it by 15, is try and get it to basically fit the box. So we go there. Okay, that looks good. Okay, now we're going to do some distorted text for this top bit. So I'm going to write Vectric UGM and get it to fit within this space. So what we first need to do is offset the vector inwards by 2 mil. Then can shift the vector over here. So basically I'm going to take out the fillets or the rounding of the corners, that's so I can then basically get rid of these 2 side lines, because we just want the top and the bottom vector to distort it with. So if we then click N on the keyboard for node mode, and then delete these, delete the points. Okay, now we've got the vectors, we just need to do the text. So if I type out Vectric UGM, close that. So what we want to do is just use the distort selected objects tool in under transform objects. So we're going to click this and then go between two curves. So we're going to select the text, the bottom vector, and then the top vector, and then click apply, and that's now distorted the text. Now that we've got that, we can, with the text selected, select this one and then center it in place. We can then delete these vectors because we don't need them anymore. And then that's that top part done. So for the next part, it's going to be the name part of the badge or the medal. So what I'm going to start by doing is creating a box. It'll fit in there. It's about 11, 12 mil high. We're then going to use that to then put the text in. So I'm going to just put my own name for the moment. So basically what we've done is by bounding it to this box, any text that we put in there, it will then fit to that box. So for example, if we had a longer name like Charlotte, it would then shrink to the size of the box. I'm going to leave it for Olly for the moment. And close out of that. So that's that bit. And then, so the next part of the text that we're going to do is the year. So we're going to put 2023 up here, just to signify when it was. Okay. So what we want to do, just bring that up and then scale it down to fit. I'm just going to do this by eye for the moment. That looks pretty good. So now that we've done all the text parts, it's now on to creating the bit down here. So we're going to insert a 12-sided shape or a dodecagon. So the way we're going to do that is if we go into this tool, draw polygon tool, and we're going to create a 12-sided shape with a radius of 14.5. We create that and then center it to here. Okay, going to move it down a bit, and then we're basically going to offset it, selecting the new vector outwards by 1 mil, so 1, 2, twice. So basically the first vector is going to be for the pocket, and then the other two are going to be the laser toolpaths. We select those and we can just line them up to where we want them. Okay, that all looks good. Okay, for the next step, we're actually going to import a vector. So if we go to documents, and then we're going to import the V. So basically this is a vector that we've been given from our graphic designer. So he saved out a DXF file so that we can use the vector for this project. If you are creating your own medals or badges, then it's probably worth asking for any graphics like logos, etc., whether you can have them in vector format, because that would really help for these projects. Okay, so we're just going to center that within there and then close that down. And then, so the last bit that we want to do is just create the map vectors for around the V. So for this, I'm going to import in bitmap. So Vectric UGM, open. Okay. I'm going to move this to over here, just so that we can get the vectors out of the way of all of these other vectors. Okay, so we're going to want to use the bitmap trace tool, and then we're basically just going to want to select the vectors that we want. If we go around, that looks like, because I only basically want the world vectors, and that's it. So we can preview that and then click apply, close that down. Okay, what we can now do is ungroup the vectors and delete any that we don't need. It might actually be easier to select the ones that we do want by deselecting them. Then we can delete the rest out of there. We can then group these objects back together and bring them over. So what I'm basically going to do is scale these down to a rough size. Okay, and then we can see if we center it what it looks like. Can actually move up a bit and across. That looks to be good. So then what we can then do is get rid of any crossover points. So what I'm going to do is go around and trim any of these. So I actually have to ungroup these onto the original layer, and then we can go and trim them like so. And then we can group them all back up together. Then we can get rid of the bitmap because we don't need that anymore. Okay, so that's all the vectors done that we need to do. So it's now time to start doing the toolpaths. Okay, so if we go over to the toolpaths tab and we split the screen so we can see the 3D view as well. So basically, the first pocket we're going to do is actually the pocket circle. So we're going to pocket this out. Okay, we're going to go down 4mm for this one and then 2mm for the other pockets. So this is going to be the deepest pocket. I'm going to choose an 1/8 inch end mill and we're going to go with these settings. Okay, I'm going to name this pocket circle. It's going to be an offset with 2 passes, and then we calculate that. Preview the visible toolpath. That all looks good. Okay, so the next one we're going to do is the big pockets, which are the outside vectors. So these ones, not these ones, because those are the laser ones. So we're going to pocket down again. This time we're going to go down 2mm using the same tool, 1 pass. So we could name this one Big Pockets. Calculate that. Preview the visible toolpath. Okay, so the next one we're going to do is actually the maker text. So this is the VCarve one, and then we're going to do VCarve text. Calculate, preview the visible toolpath. That all looks good. Okay, so the next one we're going to do after that one is the pocket on the top. So actually going to use profile cut. We're going to go all the way through our material. So Z plus 0.4. We're using the 1/8 inch end mill again. We're going to go inside the line because we want to cut inside. And we're going to use profile whole top. Calculate that. So this is basically just a warning to say that we're going to cut through all the way through the material, which is what we want. Preview the visible toolpath. As you can see, that's gone all the way through. Okay, so the final toolpath we're actually going to do using the CNC bits is a profile cutout. So Z plus 0.4 to cut all the way through. We're going to go outside because we want to cut outside the line, and profile cutout. Calculate that. It's going to cut all the way through the material again. Preview that toolpath, and then we can have a look at it in the preview. So basically the reason why we can do all of these toolpaths first before any lasering is the laser isn't actually going to move the material, it's just going to laser onto it. So we can basically do all the CNC toolpaths before the lasering. Okay, now we're going to move on to the laser toolpaths. This is where the hybrid machining comes into its own really, because we can then laser onto anything that we've carved out. So we're basically going to set up the laser to laser in these pockets and this pocket here. I'm going to adjust the depth of the laser by 2 mil because that's the depth between here and here, and I'm also going to adapt it to 2 mil down here as well from the material surface, which will be the top layer. Okay, so the first part that we want to laser is these two vectors, so the Vectric UGM. So we're going to go into the laser toolpath, and we're basically going to input the settings that we're happy with. Just to pause quickly to say I did do quite a few tests before actually kind of finalising the settings for these. So I guess depending on your laser and the settings and its power as well, you'll need to probably do a few tests before you actually commit to making your first medal or badge like I've done. So if we start going through the settings, so we're going to go for 100% power and 15% move speed, and then we're just going to do number of passes is 1. You can also edit these within here. So basically these are whatever your laser settings will be, and then basically so the maximum burn rate here is so that in the 3D preview you can alter this so it matches the color of the burn that you're getting from your laser at certain settings, so that you can get an accurate representation of your laser's power within the software. So if we just change that to 15, back to 15. Okay, so for this first one we're going to hatch fill. We're going to go with a step over of 1 mil, and we're going to hatch fill at 45 mil degree angle. We're going to cross hatch and outline. So that means we're going to go diagonally across this way, and then we're going to go around with an outline. So that then means that the text and the outline will really be exaggerated, which is what we want. And then we can rename this to laser cut Vectric UGM, and we can calculate that and then preview it in the preview. So as you can see, that effect is going to look really good on the contrast from the pale wood and then the darker laser where it's been. Okay, so moving on, the next toolpath we're going to do is the outline. So select that one and then these two, because we've already pocketed out this one. Going to go up to the laser again, and we're basically going to set the power to 100, the move speed of 15 mils per second, pass rate of 1. On this one we're going to cut on the line. So basically if you're going to cut on the line, it's going to grey out all these settings because these are basically just for the hatch fill. And then we're going to rename this one outlines, calculate that, and then preview the visible toolpath. The reason why I've gone for this one is just to exaggerate the pocket and also this middle bit to draw attention to it. Okay, so the next one we're going to do is the name. So this is pretty similar to the last laser toolpath we did. So we're going to go with 100, 15, 1, cut on the line. And then I'm going to rename this name and calculate that. You could run both of these laser toolpaths at the same time, but I've decided to run them separately. So the name and the outlines, just in case I want to make the name a bit bolder and run the laser toolpath again, I can do that. So that looks good there. Okay, so the next one we're going to do is 2023. So this is a little bit different. So basically what we're going to do is we're going to go for 100% power, but a move speed of 20 mils per second. We're going to hatch fill. We're going to use a step over of 0.5 mil, and we're going to change the hatch angle to 0, so it's going to be going horizontal now. And we're not going to cross hatch, we're just going to hatch fill along those lines, and then we can put 2023 here, calculate that, preview that, so it should come out really well and create a cool effect on there, which is just something different. Okay, so next it's the map part. So we're going to go in here, going to go with the settings of 30-20, fill 0.4, 45-degree angle, and then laser map. Calculate, preview that toolpath, that looks good. Okay, so the last one, the V. So we basically want the V darker than the map, so we're going to go with these settings. So we're going to go 100, 21, 0.4, and hatch angle of 45, and we're going to outline it as well. And then laser cut V, calculate, preview that toolpath. Okay, that's all looking good. Okay, so now that we've done all our toolpaths, all that's left to do is save them out and get into the labs. Cool, I'm really happy with how that's turned out. Now let's get back into software to create a bunch of these that have been personalised with a plate production feature. So the plate production tool is a really helpful feature if you're making multiple versions of the same thing. For example, these UGM badges or medals. So basically what it does is it takes a list of fields within a CSV file and it then outputs them into the software, duplicating all the toolpaths and all the vectors for as many fields as you have. So it's a really quick and easy way of outputting lots of data and lots of the same thing but in a very easy way without having to copy all the vectors and then go in and edit all the names, etc. So the first thing we need to do when thinking about what we're actually going to do for the plate production tool is work out what fields we want to change. So in this example, I'm going to be changing this field, so that's going to be called role, and then this field, which is going to be called name. So basically, when we go into the spreadsheet, we're going to be creating two columns which match up with the amount of fields that we want to change. So if we just go into a blank spreadsheet, we can start to create the data that we need. So first column will be name, and then the second will be role. Obviously, the more columns you have, the more fields that you can change within your design. So these will correlate with the variables that we select within the software. I've already pre-populated some data that I've just copied in. So I've got basically a list of names and then a list of roles that I want to create the medals. As you can see, we've got 41 fields here, which is 42. So if we exclude the top line and just this data here, we've got 41 medals that we want to make. So the next step will be saving it out as a CSV. So if we go File, Save As. So within here, we want to basically be saving it out as a CSV. So if we go down to this drop down, text CSV, we can then rename this to data full list of medals. Click Save. This will then bring up this, so use CSV. And then basically within here, we want to click the drop down, select the comma one, and then the string delimiter is quotation marks, and then save the cell content as shown. We don't want to formulate anything. Basically, we want to save it out as a basic CSV file with commas to separate the values. Click OK, and that will save that out. So now that we've got our data in our CSV, it's time to get back into the software and import the CSV into the plate production tool. So for the plate production tool, you might be thinking, well, how does it know what fields to change and what to stay the same? So basically for this design, I want Vectric UGM in 2023 to stay the same. I want the maker to change to whatever the role is and the name to change to whatever the name is. So if we just go in here, and basically the way that the plate production tool realizes what are the variables or what fields it needs to change is by putting exclamation marks either side of whatever the variable name is. So for example, this one would be role. Then if we just go into the name field, change it to name with the two exclamation marks. So they're the only two fields that we really want to change. If we did want to change others, we could put more in. There isn't a limit on any amount of fields as long as they correlate to your CSV file. So next thing we'll need to do is, obviously we need more material because this is just enough material for one. So to start off with, I'm going to create quite a big sheet, and then I'm basically going to show you how, depending on your size of sheet, it will depend on how many sheets it then outputs. So if we start off with quite a big one that will fit all of the medals we want into one space, so I'm going to go with a width of 700 and a height of 650. Click OK. And then go back to the drawing tab. So for this part, I just want to reset the preview and make sure that we've got all the toolpaths we want, because basically once we've used the plate production tool, it's quite hard to change any of the toolpaths or any other vectors within it. So it's worth checking that you've still got all the ones that you want. Okay, because we've increased the sheet size to quite a large sheet size, it's now looking blurry. So a top tip here is you can go into toolpaths, preview simulation, and set it to whatever level you want. Obviously this is personal preference, and if that was okay for you, then you don't need to change this because it will slow down your previewing time. So we preview all toolpaths again. And as you can see, it's much clearer now. which is what we wanted. I can definitely see that we've got all the toolpaths in there we want, so it's ready to head over to the plate production tool. So if we highlight those, so these are all the vectors, and all within those all the toolpaths that we want the plate production tool to use. So if we click on here, so this will open up this window. So it's basically taken our sheet size and the plate width as well. So the sheet margins is basically how much space you want around the sheet. So we can set them equally, or say you wanted more room on the top, we can change them to have more room on any side really. But for now, I'm just gonna go with equal margins of 10. Spacing, so the only tip I have for this one is you're gonna want the spacing definitely larger than your bit, so there's plenty of room between each one. So otherwise, obviously, your bit's going to cut into the one below or above it. So that's a good tip there. The number of plates, so it's automatically calculated the size of the sheet and then what the best way or the number of rows and columns is. That's good. Okay, now we need to import the file. So if we go full data list, open. This is imported in all the data. And then we now need to say how we formatted the data. So I've actually used comma separated, and I've also included the name and the role, as you can see, as the first column names. If that was unticked, then that would then count as one of the medals, but we don't want that, so it's going to discount that data. We then need to select the right variables, so the right data. So we've got role, which I've assigned to role, and name to name. Obviously, sometimes when you're importing in the data, these might be assigned to the wrong field, so you just need to double check this. And then the type, you can do number or text in here, but all of ours are text formatted. Okay, so now that's all that's left to do is click calculate. So this is basically just going to go through and duplicate all of the toolpaths and all of the vectors with the names and stuff. Okay, now that that's all done, we can close out of this, and then we can check what the output has been. So as you can see, we've got if I full screen this, got the attendees towards the top, got the makers and the educators in between, and then we've got the presenters along the bottom piece here. So that all looks good. And if we head over to the toolpath preview, full screen that. So one helpful thing is it will automatically, once you've calculated them all, only select the toolpaths associated with that sheet. So you can reset the preview and then just preview visible toolpaths. If you did preview all, you're going to be previewing the one medal toolpaths as well, which we don't want. So as you can see, it's just going to go through and run all the toolpaths. So it's going to start off with the circle, then the pockets, etc. One thing that we are actually going to do is move the VCarve toolpath up, so that will make our machine a lot more efficient, because then it will be less tool changes rather than changing from the 1/8 inch end mill to the V bit and then back to the 1/8 inch end mill. As you can see, as we've got it on a higher preview resolution, it's taken a bit more time. Yeah, it's all done, and then we can zoom in and see if it's all as we expect. Those are all looking good. So for the next step, I'm actually going to create the file that I'm actually going to use to cut 3 medals on the machine. This is due to like the machine size and the material available. Okay, so just going to edit the sheet size to what I need. So that will be 200 by 280, thickness of 6. Okay. Can highlight the vectors I want and the toolpaths. go into plate production tool. So we've actually got another file saved under here, so data, which is just the 3 medals I want to produce. We've got the role and the name. Hit calculate. Is that that? Okay, so that's looking pretty good. Go over here. Okay, one thing I need to do is put the VCarve in first, because that's what we're going to do for efficiency. And then we're going to change to an end mill and do the laser cuts. If we reset that, preview the visible toolpaths, VCarve in first, and we're going to do the deeper pockets and the bigger pockets. Then we got the top pockets and then the profile cut. We're going to be holding the material down with double-sided tape, because then we can actually profile cut around the medals to give it a smooth finish. Full screen that, they're all looking good. So all that's left to do is save out the toolpaths and head over to the labs. So there you have it, a set of bespoke medals that have been personalised and efficiently machined. So just to recap what I've covered in this project, so I've done hybrid machining using the laser module. I've also used the plate production tool to turn one medal into several medals, and I've also used the drawing features within the software to create the vectors for the medals. I hope you have enjoyed this project. All of the files that I've created are included in the purchasable UGM bundle available on the website. If you have any questions on anything included in the project or in the video, please leave a comment below and I'll get back to you. Thanks for watching and happy making.